All right. Hello, everybody. Welcome to today's workshop. It's so good to see people popping on for all over the world. We've got Zoom going. We've got YouTube going. If at any point you've got questions for us, just drop them in either chat. I'll be monitoring that. Today, we are focusing on the first session we're going to do on optimizing data analysis in Python using Pandas. We're going to focus a lot today on auto exploratory data analysis and look at some more sophisticated ways to get involved with working with data frames. My name is Alex Chisholm. I am the co-founder of Data Query, a site that we started a couple of years back to really surface data science learning opportunities for people to find free online training and videos or textbooks, maybe find a graduate program or a certification. There's so much out there today. And today, obviously, we're focusing on Pandas, and you'll find a lot of information on the site and elsewhere on things that you can learn right now for free. So I definitely encourage you to take a look. Overall, we've got 2,500 courses right now on the site. But I'm joined also by my co-founder, David. David is in North Carolina. I'm in Pittsburgh, Pennsylvania. David, do you want to say hi to everybody?
Hi, everybody. Yeah, thanks for joining. I'm very excited to host this workshop today. We're going to be focusing on Pandas and these, I like to think of these workshops. These are going to be a bit shorter than the ones we previously had, and they focus on all of the tips and tricks and new tools that Alex and I have picked up over the years working with Python and Pandas. And hopefully, our goal is to get your data analysis to be more efficient and your code to be very clean, and for you to discover these new tools. So I'm excited to share that with you today.
Yeah, and we've got a few people on the call. I just want to do a quick poll right now to see how comfortable people are just coding in Python in general. So I want to get a sense on where you are right now in your Python programming journey. So if you could click one of these for us, we'll let you know. We've got most people on that slightly to moderately comfortable side. So you're feeling pretty good in the tool. We've got somebody who is extremely comfortable as well, which is fantastic. And I know a lot of the times you can do a lot, right, in Python with other packages or with base Python, but it helps when you get into some of these helper packages like Pandas. So I'm going to drop one more in just to get a sense again on Pandas now. So have you experienced using Pandas for this analysis? Yeah, so most of the people that are writing in right now, they're a little bit less comfortable overall than what they've done with Python in general. So hopefully this can be that starting point for you to get things done quicker. All of our organizations, right, have spent a lot of money and time in recent years getting data into systems, cleaning it up, connecting it. And then a lot of the times it's our job as a data analyst to say, well, I'm going to go find the information I need, try to make sense of it, try to piece it together. And then ultimately you're going to clean it up, and then you're going to try to find some way to understand what's happening. And these helper packages that are out there really make this task a lot easier for us, which is what we're going to get into today. So if you are coding in that R ecosystem, maybe you're going to turn to the dplyr and the tidyverse. But Pandas is definitely one of the go-tos still for Python, and that is the focus for today. So without anything more to say, I think I'm going to hand things over to David to share his screen and start walking through some live code. I will make a link to this available in the chat, both on YouTube and Zoom as well, and we can share it with everybody after the fact as well. And once again, before you get started, if anything comes up, if you've got any questions, just drop a note in the Q&A box or chat, depending on what platform you're on, and I will take care of it.
Awesome. Yeah, thanks a lot, Alex, for the intro. And so let's get started. So we have this. So this is in DeepNote. So if this is your first time joining us, this is a notebook platform. It's really great. So this allows you to do Python data analysis and coding, in a cloud-based editor. So you don't have to worry about installing anything on your laptop. So it makes things very easy. So let's go ahead and get started. So whenever I have a notebook, I always like to import all of my libraries in the first cell, just so that we can see all the packages that we're using. And so the main packages we'll be using will be Pandas today. So we'll be importing that with its typical alias as PD. And then there's a package, if you've not heard of this one before, it's known as ydata-profiling. So this used to be called Pandas profiling, but they recently made a change to their name because they're expanding the capabilities of this package. They're adding also Spark support, which is going to be great. So if you ever have to work with very large data sets, so I'm talking millions, potentially billions of rows where you're working with Spark, you'll be able to use this profile report from this excellent package as well to run your auto EDA analysis. So it's a big time saver, this package. So we will be working with a employee data set here, right? So we're going to load this from our environment. And the nice thing about DeepNote is whenever you print out a Pandas data frame to the console here, you get this really nice summary. So it's almost like it does a bit of auto EDA for you automatically. But here in this data frame that we'll be working with, every row represents an employee at a particular company here. I believe this was from somewhere in the Midwest in the US. And so the column of interest here is left company. So this was a study that was done by the Human Resources Department there, and they're tracking their employee retention, right? So do people tend to leave our company or stay in the long run? And so that's the outcome column here. So here we have a lot of yeses and nos. And you can see that the majority, so no, we have about 84% of employees ended up staying at the company. So they didn't leave, but a small, subset, 16% did. So we also have things like their department, which is the second column, also their job level, right? So are they a director or manager? And then some really interesting features here. So we have their salary, how many weekly hours they work. So these are all based on surveys. So they surveyed their employees and got this data back from them. But this would be their average weekly hours, if they were to estimate how long they spend at tasks at their job. So this first person here would be 56 hours, which, is quite a bit if you compare it to the standard 40-hour work week here. And then do they travel and how long they've been with the company and all sorts of, really great features here. And at the very end here, job satisfaction, performance ratings. So those are also based on survey and then also year-end performance reviews, right? So how is this person satisfied with their job? And also how are they rated by their manager? So all of these things are really great predictors if you were to want to write a machine learning algorithm to predict, whether somebody has a propensity to leave the company or not. But typically before, you run a machine learning algorithm, what you want to do is prepare the data, clean it, and also do exploratory data analysis. So that is what most people call EDA for short. And there are a lot of helper packages in addition to Pandas that will make this much easier than it has to be, right, for us that kind of automatically do these graphics and data exploration. But the first thing I wanted to start with, just in the light of having this be tips for Pandas, just to help make your data cleaning and analysis a little bit better, is I wanted to focus a little bit on one of my favorite methods from Pandas. It's known as query, and it is extremely powerful. So I always like to, if I were to summarize this method, to me, it's just a huge time saver. It allows you to type logical conditions and expressions in a SQL-like syntax as a string. And you can just simply type the names of the columns and the values you're interested in subsetting your rows by. So it really does save you a lot of time. If you've ever had to subset a Pandas data frame using things like loc, L-O-C, or maybe iloc, there's a lot of typing there. You have to type out all the column names and subset, and so things can get very messy very quickly. So this is a nice, elegant way to kind of filter your data. So I've broken up kind of this query by different examples. So the common use cases that you'll run into when you might want to use this. So the first set of these special cases is whenever you have logical conditions just based on your column values in your data. So these would be questions such as, I need to subset my data frame for just the people that did leave their company, right? So here we're looking for, is left company equal to yes? So that would be our logical condition. So the great thing is that you could just go ahead and start with your employee DF data frame. And then to access this method, you will do dot query. And then inside, you will build up your query string. And so here you can access the name of any column that you would like in the data frame. So here I've typed left underscore company, and then I have double equal sign, and it's equal to the string yes. So typically one tip with these query strings is I always surround them by these double quotes, because if you're ever having to subset a column that is a string, then you can go ahead and put a single quote around the value inside of that. All right, so this will go ahead and give us a subset of our data, and it should be around 200 or so. Yeah, 237 employees here. And you can see that the left company now value is set to yes. All right, so very easy way to subset your data. Now, another helper function is the in operator. So if you've ever worked with SQL before, this is almost exactly identically how the SQL in statement works as well. So here I am trying to find employees from employee EDF that are only in sales and marketing, right? So I'm just interested in those two. So the way I could use query for this is I will access the department variable inside my query string, and then I'll use that special operator in. And then we can go ahead and put inside of a tuple, since we're in Python here, those two strings that we're interested in. So we're interested in sales and marketing, and each one of them is surrounded there by the single quote. All right, so this is a nice quick way to find people that meet just those two conditions. All right, so you can see everybody now. So we have 490 rows that we got in our results, and we have sales and only marketing here in the end.
Hey, David, I've got a question coming in on performance. Do you know how this compares to LOC and iLOC and other methods in terms of performance on larger data sets?
Yeah, so it is a little bit slower, but not much, because what happens in the back end here, there's a special function that will take this query string and it has to translate it into the code that's being written in the fast version, behind the scenes. So you get a little bit of a slowdown due to that, but I would say it's negligible. It doesn't really make a difference in performance. Yeah, but that's a great question. And those differences are going to be even less in the new version of Pandas, which they are releasing 2.0 pretty soon. And the backend for that one now has become PyArrow, which is going to be way faster than this version of Pandas. So I'm very excited about the things to come. And another reason that's a really good question is Pandas, if you have more than, I would say, 5 million or so, or 6 million rows in a Pandas data frame, then things really, really slow down in Pandas. And that's one of its kind of weaknesses, and everyone knows that. So I think the Pandas team is really working to try to solve that problem. I'm excited to see what will come out of that work.
That's some great context. Thank you.
And here I wanted to show you, again, this is a trick that took me a long time to discover, but it makes your code very clean. So I really wanted to make sure to share this with you. So the great thing about query is you can have a multi-line, very, very long, complex kind of logical condition, and you could write it in a very clean, concise way. And so here, for my query string, I'm going to have 3 conditions that I would like to make sure that are met. So here, the first one is department is not in research, sales, and marketing. So notice I use this new operator here, not. So it's an easy way to negate any operator and or in this query string. So the way you want to set up these multi-line queries is I like to enclose every single condition in parentheses. All right, so this would be my first condition. And so in there, I'm looking for people from a specific department. And then I'll put an and operator. So and this next condition has to be met as well. So if you want to separate this onto a new line, all you have to do is inside of your string, add a backslash. And this will allow you to do the line continuation. All right, if I were to remove that backslash, this query string would fail because by default, it doesn't allow multi-line statements to be evaluated. All right, but whenever you do this, you can go ahead and continue on the next line. Right. And then my next condition here is I want their salary to be at least $100,000. And I also want them to have an average weekly hours of greater than or equal to 55. All right, so it's a very clean, elegant way to go ahead and have these really complex multi-statement queries executed. Now, so the great thing is not only so it saves you time, but anybody that will come in after you to do your analysis or maybe read your code, it's much easier to see what you were trying to do without even having to write a comment here. So this is a really good tip. So I always recommend if you have complex queries, go ahead and separate them into multi-line statements so that they're easier to follow with these backslash operators here in your string. Right, and you notice that we did get the correct thing. We don't have anybody from research, sales, marketing. Everybody is making more than 100,000 here. If I look at the salary column, and same for my weekly hours, everybody's between 55 and 66. I worked correctly. And a nice, elegant way to do that. Now, the other powerful idea here behind these query strings is that they're able to take data from outside systems. And so here I have a really simple example here. Let's say that my max salary, so the people I want to cap people at in terms of my study would be maybe $120,000 a year, right? So I'm coding this in this variable, max salary. And then I'm able to pass that into my query string and use it for a logical condition. So here I'm filtering all the salary values that are less than or equal to that. So you simply have to use an at operator. So it's the at symbol. And then you can reference this external variable from your string. And so this will go ahead and filter our data for all those employees that are making less than that. So also very powerful. And this comes up in production quite a bit, actually, when you're cleaning data and then you have to periodically update the data cleaning. So typically you will have these kind of metadata indicator variables. So things such as run date or clean date, right? So typically in Python, you will load in and you'll capture today's date and time. And then maybe you need to filter your data frame based off of that exact value, right? So that's a perfect use case for when you would want to be using this type of methodology. So capture dates and times, and then go ahead and slice your data based on that particular time. And that's also useful for if you're ever doing calculations and dashboards and things like that in real time. So this comes up quite a bit in production. And then we also have column expressions. So I did want to spend a little bit of time here. So you can also use Pandas series methods inside of query to directly evaluate those column values and then filter your data. So this can become very, very powerful inside of these query strings. So a common use case for this is regular expression handling and string methods. So we do have a couple of string columns in our data. So department is one of them. And so here inside of my query string, what I'm trying to do is find departments that end with an S, let's say. So what I'm doing here is I'm accessing here the department column, and then I'm doing a .str. So in Pandas, whenever you do a .str on a string column, you're accessing that column's string methods, right? So you're accessing the series string methods. And here I've added the documentation for Pandas here for all of their string methods. And one of them is ends with, right? So now this is typically how you call these string methods. So you'll have some column .str and then .method, whichever method you're interested in. So this will give me this ends with, will give me all of the columns, the rows where the departments end with an F here. Right, so we're good to go here. Sales, finance and operations, IT and analytics. So they all end with an S there. So this is a really simple, regular expression work here where you're looking just for things that end with an S, but you can do more complex queries. So the great thing about query is it also takes regular expressions. So this is if you have something that's really complex. So if you're looking for a certain string that's in the middle of a word, or if you're looking at something that comes after the letter B in a sequence of strings. So this is where you would have to turn to these regular expressions. But the query method allows you to do that. So here I'm tapping into department again, and I'm accessing its string methods. And there's a method named contains, where I can use regular expressions here. So here I'm saying contains, and then this funny string here. So this is known as a regular expression. And what that means is that it either ends with an S, and then the vertical bar that represents, or it ends with an ing. So anytime you put a $ at the end of a string, that means that you have to end with that. So whenever you set this option to true here, regex is equal to true, it's going to evaluate that string as a regular expression. Now you get all of the ones that end with an S or an ing. And here I wanted to show you, if you can see it, I already have it open. Regex1 here. So Alex, do you see this in my sharing screen?
Yep, we can see it.
Yeah, great. So I highly recommend this for regular expressions. This was a lifesaver for me a couple of years ago, where I had to get up to speed on this very quickly. So you could learn this in about an afternoon. So this is a series of 14 free lessons here, and it will tell you everything about these regular expression operators. So 90% of the complex strings that you're interested in subsetting, you'll be able to use with these functions. And it's really great. Every lesson introduces what this is, and then you get practice at the bottom of finding things, right? So here, if I wanted to find things that end with a C, it tells me it only matches the bottom one there, right? So you go through each one of these, and you will become a regular expression master there pretty soon. And then you'll be able to use this in Pandas here. So I highly recommend that. And the last one is numeric column expressions. So again, here we're going to be accessing Pandas series methods again, but this time for columns that are numeric data types, so either integers or the float-based ones. And so here, for example, if I was interested in the top 25% of employees based on their salary, I could use this type of expression. So here, my salary is greater than or equal to. And notice inside of this expression, what I'm evaluating here, I'm taking salary and dot max. So that's going to give me the maximum salary value inside the whole entire data frame. And I multiply that by 0.75, right? So every salary value that's greater than that or equal to will be the top 25% here, right? So also very helpful that you can access these methods for numeric variables as well. And this allows you to do really complex things, right? And especially when you bring in the between series method here, which I'm introducing here. So this is one I find that I use often myself. So here in this one, I'm saying salary dot between. So I'm using the between method. And then inside, it takes two parameters, right? So what's on the lower end, what's on the upper end. And then inside I have salary dot quantile. So that gives me the 25th percentile. And then I also have salary dot quantile 0.75 for the 75th percentile. All right, so this will give me people inside of what's known as the IQR, interquartile range for your salary. But this is how you can do it with all of these expressions inside of query. Makes things a lot easier to follow and very quick. And then finally, I wanted to include a ranking as well, because this is a common task we have to do as well. So things like find the top 10 earners, for example. So with this one, we access the rank method from the salary column. And here I simply say ascending is equal to false. And I find the first 10 here in this case. All right, so this will filter my data frame here for all of the top earners here, the top 10. right? And notice here, everybody's either a vice, they're all vice president, making a nice salary there at this company. Right, so that's query in a nutshell. There's a lot more you could do with it, but hopefully you can see how powerful it is just from these short examples here. Another kind of hidden function that most people don't talk about in Pandas, but I think is extremely helpful, is filter. I want to show you just quick examples here of filter, but this is yet another way to select columns. And you can do it by accessing this filter method from the employee. So here I do employee df.filter. And then items, whenever you enter a list for items, here you enter your column names. And then when you select access is equal to 1, this will just subset and give you back only those columns. Right, so this is a alternative to using imloc or loc, or just a simple list to subset your data. And this will be helpful when we go over Pandas pipelines. So when I introduce the pipe function in a later webinar, using this will help us out a lot. But the most impressive feature of this filter is it allows regular expression filtering for your columns. So that's not something you can do with just the typical base Pandas. And so here I'm putting into filter, there's a option regex, and I'm saying I want to make sure that it ends with company. So whatever columns I get back on my column axis is 1, it's got to end with company. So this is, again, another quick way to filter your data, right? Without having to look through, what are all the columns, which ones end with company, and actually manually making a list out of that. This can do it for you automatically. So really great. And then here, just to show you another different way of doing this, here I have regex company or year. So it contains the word company or years in the column. And this is what I get back. I believe I get back 3 columns here. Yes. Right. So either one contains either years or company or both. So it's very versatile and very nice feature. All right. So that was kind of the tips and tricks for filtering with query and also selecting your columns with regular expressions. I think those are very helpful. Now, the last section, the thing I wanted to cover is this special package. I've really come to love it quite a bit. Why data profiling? I have a link to the documentation here, and I urge everybody to check this out. So the way this works is to create a profile report. We have imported this from Why Data Profiling. It's a class profile report. And the first argument that it will take is a Pandas data frame. And then you can provide an optional title here for what you want to title your report. And then once you've created this profile report, the way you can call it inside of a Jupyter notebook is you access its .toNotebook iframe method. And what this will do is it will compute a nice interactive report that you can see here inside of your Jupyter notebook. And it's got a lot of really great summaries. So it has an overview section where it tallies how many observations you have, columns, and things like how much memory you're using. And then we can cycle through all the variables. So it does a simple summary of all of the columns in your data. And you can select each one by selecting the column here at the top. So you will get a histogram for numeric variables. You will get a nice summary of how many things like how many zeros there are, the minimum and the maximum. And you can also click on this more details button here at the bottom. And then for each one of those numeric columns, you get a really detailed summary of all the summary statistics you would ever want to calculate. Things like skewness and kurtosis, standard deviation, and mean. And you can get a closer look at your histogram as well. Right, so this is really great summary, quick way to look at your columns. And if you have something like department, which is a text column, you will by default get a bar graph counting the number of items there. And then here you can look into categories, you can get a more detailed breakdown. And then it also by default looks at words, so how many words appear in your column. and then does a summary there. So you get a lot from this. And then we can also look at interaction. So here I'm looking at the top tab. I have variables and then interactions. And it will plot all the pairwise scatter plots for you. It's in a special format here. This is a scatter plot, but it's really kind of a density plot. So each one of these hexagons here, the darker it is, the more points there are in that region. So think of it as sort of a heat map. But this is a quick way to explore things like, what's the relationship between salary and number of previous companies, right? And it will show you where people fall on this spectrum here in your data. So really great as well. And then it will also calculate correlations by default. So the default behavior here is it calculates the Pearson correlation, which ranges from -1 to 1. And it will give you all of the columns that are heavily correlated with each other. It's easy to see in this nice heat map, right? So you get all these plots here. And then here at the end, we don't have to worry about this, but it does do a missing value analysis. So here it's a plot here that plot the non-missing rows in each column, but for us, it's not that interesting because we don't have missing data, right? You get a count, you can also get something known as a matrix here. So this is important if you have missing data. And then finally, you get a sample of your data at the bottom. All right, so this is the default behavior of Pandas profiling. And I think you get a lot for just that one simple line of code, right, that we put together. So having to code this up manually with Pandas would definitely be a lot of work. So it is a time saver.
Hey, David, in terms of sequencing, when you're going through a new data set, do you tend to spend time first with the raw data, just looking at it yourself to get a sense for it, or do you go straight into something like this, a profiling report?
Usually I will go straight into the profile report, but I will only look at the variables tab first. All right, so if I make my way all the way up to the top here, so I will explore each one of those variables and I will focus on the numeric ones as well. So here, let's see, salary maybe. So this is where I'm focusing on the distribution, right? Do I have a lot of skewness that I have to deal with and extreme values in my data? I'm always looking for how many missing values, how many outliers I have in my data, because those are the top problems that you run into with machine learning models that you really have to watch out for. All right, skewness, outliers, and then high correlation among your variables. So I definitely start off with Pandas profiling just to get a sense of what's going on before I do any type of feature engineering, as it's known as, to correct those issues. And if you do have a large data frame, so let's say you do have a Pandas data frame that's 10 million rows. If you try to run this Pandas profiling on that, it would take a while. It would probably take maybe 20 minutes or so to put all this together. But what I like to do is I take a random sample of about 1 million rows from that data. So you get a nice representative sample. And then I have a look at this Pandas profiling first before I go into all my transformations and things like that. So definitely a great tool. I mean, I use it almost every week at work, actually.
All right.
And that's on huge data frames. And the last two examples, we're going to get the same, profile report, but I did want to show everybody here that you can customize the appearance. You can customize the things that are calculated in these reports, which makes it great. So here I'm doing another call to profile report. And this time I'm adding some additional parameters. I'm saying missing diagrams is equal to none because we don't have missing data, right? So we don't need it. Samples, none, because I don't need to see a sample of the data at the end. And then here I'm adding things like which correlations I would like to see calculated, right? So for me, I would want Pearson to be calculated. And also this one I use often is called phi k. And this one is good. And then you can optionally pass variables. So this is a dictionary where you define this variable in the data means this, right? You can have a nice description of your data. right? And there's a lot of these available customizations. So I've added a link here in the notebook. If you click on this, it'll take you to the documentation where you can see everything. But I wanted to show you just what that looks like with these kind of custom additions here. All right, so notice we only have these 4 tabs now. We don't have the missing data at the end. Each one now has a description. Each one of these columns that we select, right? Job level. Now you see employee job level. So that's the description I provided. So it allows you to customize things. And then finally, the very last one, I think this is the most important feature, and it's the newest one for ydata, is there's a function that's called compare. And it allows you to compare 2 profiling reports to each other. And typically what you do is, if there's something you're trying to predict, like we would be in this case, left company, so there I have yeses and nos, you would want to create a profile report for the yes group and then for the no group. And then you can use this function to compare them. So that's what I've done here. So I've called this report left company and this one stay company. But I'm simply building these Pandas profile reports, but I'm adding a query to my data frame here. So here I'm only selecting people who did leave, and here people who did not leave. So once you have those 2 reports that you've created, all you have to do is create one more, right? So you take the first report, left company, then you do dot compare, and then stay company. And this will create a special Pandas profiling report where it will highlight each of these 2 groups for you. And you'll be able to compare their output. All right, so you'll have churned employees and then retained employees, since that's what I labeled them as. And so now you'll be able to explore your variables by these 2 groups. So you get the different counts and things like that. And it's really powerful here on histograms, because now you get a histogram with an overlay for these 2 groups. So again, this is another common thing that I use pretty much on a daily basis almost, just to compare people in my outcome, the thing I'm trying to predict. All right, so that's all we had for our shorter version here. Hopefully you got a lot of value from this, a lot of great functions here that we're working with, great methods. And I feel like Pandas every day is getting closer and closer to, if you've ever worked with R, dplyr and tidyverse, the syntax of the 2 is becoming very similar, and they're both becoming very fast and just easy, to do data analysis with this. Yeah, so
All
I
right.
think we
Yeah, that was great. We do have a few questions that came in. One was more logistical. What are we going to do with the recording? It's being streamed right now on YouTube. So you can go to this link and you'll be able to get it as soon as it finishes up. We'll clean it up a little bit and we'll send it out via email next week as well, along with links to some of the other resources. Here's a new question that came in specifically on Pandas, Dave, and then I've got one more on careers. This one is, does Pandas have built-in support or methods for regex, or is it necessary to import the RE module and library?
Yeah, so there's a lot of those string methods that have it built in. So if you have a Pandas series and you use contains, and then you select regex as true, it's built in, right? So you don't have to worry about that. And it's also built in with filter. So the example I showed. So yeah, I think you're okay without importing the RE module. Now, there have been cases where I did have to import RE specifically, but I believe that's because I was doing work outside of Pandas and I had to do extract some patterns from text and then use that going into a filter as a separate variable. So yeah, I think you're good to go. It's pretty much built in to most of those text functions that you look at, but not all of them. So some of them don't have it. And if they don't, that's when you would have to do the RE module to do it.
Great. And then there's a generic question on careers, and it's more about how do you demonstrate to employers that you are sufficiently skilled with something like Pandas?
Yeah, so the best way to do that is, well, you'd have to showcase a data analysis, a fairly complex data analysis. So you would want to find a data set that you're really interested in. So maybe go on to kaggle.com or some other source for data. And you would write up your analysis and then publish it to the web. And there's many ways you can do this. If you're using DeepNote, for example, you could build up a notebook here, and then you see this publish button here on the right. You can publish each one of these notebooks, and it's going to have its own unique URL. So you could add this to your GitHub page as a published notebook and have a really nice analysis, right? So this is where you'd be able to demonstrate some of those complex functions. So if you would show things like query and filter and really advanced applying functions across columns, then most people who work with Pandas would be able to tell, right, that you're highly skilled in that. So I think that's the best way, is just to point employers to your work that's already online. The second best would be a certification of some kind, from either maybe there's LinkedIn Learning, DataCamp has those now, and so that works as well. But nothing compares to showing your actual work that you've done. That's number one.
And for many of these, you'll probably have to go in and show them in the interview as well somehow that you've got this and be able to demonstrate it in real time. So for those of you who are considering sending something in or have been asked to send in for a job interview, because there's obviously so much code online that can be copied and just sent in, like it's hard to really attribute it to you. If you have the time and you can get the data that is relevant to the job position in some way, that'll help you stand out also just in terms of what you've been looking at. Like once, 6-7 years ago, I was applying for this job, and it was a job kind of outside of the traditional companies I'd been with in the past. So I went to their website, I scraped a bunch of their data, and then I turned in sort of a coding project along with what was based upon what that organization did. And I think it was a really helpful way to open up at least that first interview a little bit more easily.
Yeah, that helps a lot whenever you do things like that. And thinking back to my interviews in the past as well, I always took time to bring examples of my work if I had an in-person interview. So I would write up also a PowerPoint of what I did, why I did, examples of my output from my models and things like that. And employers love that. I mean, their faces would always kind of, light up whenever you would do that, because so any initiative you take to do that, right? To do special analysis, publish it on the web, show up to the interview with that. I think you'll be ahead of, we can make up statistics here, but I think you'd be ahead of 80% at least of the applicants.
That's a big number you made up. That's good.
You
should have said 82% though. It would have sounded more believable. All right, last question, David. Pandas is obviously one of the leading, if not the leading ways to sort of wrangle data within Python. Do you see other packages that are emerging, other libraries that people should be looking at too for this specific type of work?
So yes and no. So Pandas is definitely the most commonly used, and it does have that problem of big data size. So you can't really get around that. So there are ecosystems built around Pandas to handle that problem. So if you've ever heard of Dask before, it's just a way to get your Pandas data frame and split it up into maybe 1,000 mini Pandas data frames and then do work on them. But the syntax is very similar. So if you know Pandas, Dask is pretty easy to pick up. And then I would say the number one contender, if there was anything that would take over Pandas, it would be Spark, right? So if you've ever worked with Databricks or Spark or anything like that, that's a really good skill to have. And so doing data analysis with Spark is a bit more difficult. The syntax is not like Pandas, and it's a bit harder to pick up. And so the Spark community has realized that. And what they've recently done is they've made a Pandas API on Spark. So version Spark 3.0, I think the newest version, has that Pandas capability built in. So I've actually switched over to that at work, because at work I have to use Spark because the data sets I work with are billions of rows. So there's just no other methodology. But thankfully, Spark community has released that. So it's called Pandas on Spark API. And it's exactly like Pandas. I feel like I'm writing Pandas code, but my data frame is 1 billion rows. So it does take a little bit longer to execute things, but the syntax is just remarkably very good and very similar. And I think over the years, that's only going to grow. And it's going to become a twin, I think, of Pandas in the long run. So if I were to recommend to anybody, what to learn, it would be Pandas. So don't worry about the big data, because all of the big data providers are taking Pandas syntax because they know everybody already knows that, right? So they're kind of working their syntax into that ecosystem. So you'll be covered.
All right, that was fantastic. I think we've covered all the questions that have come in. So thanks everybody for joining. Thank you, David, for another great session with a lot of information. If you enjoyed this and you haven't been with us before, you can check out that YouTube channel, and you'll find a long series. I think we did 6 one-hour sessions on machine learning with scikit-learn in Python. So if that's something you're interested in, you can find some historic video on that. And I do encourage you to make it to dataquery.com to find these courses, almost all of which are free and can be really helpful as you're going through building up skills, applying to jobs in a variety of data science and data professional work. So thank you so much. We'll probably do another one of these in 2 to 4 weeks. We'll reach out via email, and feel free to hit us up anytime at any one of these destinations. And we'd love to have a conversation about your path and your data career. Have a great weekend, and we hope to talk to you soon.
Thank you, everyone.